Identifying and verifying values that satisfy two linear equations. Previously in this course, we've talked about linear equations that represent one line. Now we're going to talk about graphs that have two linear equations, where we have two equations and we're looking for the point of intersection, or the point where those two lines cross. You can see in this graph on the left that our point of intersection is right here. That's where the red line and the blue line cross. And we can see what the value of that point is. Let me label it. It looks like that is at -4, -1. So we would say that -4, -1 is the solution to the system of equations that we see here, because this point is a solution to this line, this equation. If we were to solve it, this point would be on it. It would be a solution of it. And the other line as well. It's a solution of both relationships. Let's take a look algebraically at what that means. So I have two equations here. Y equals 1/2 x plus 1, and y equals -3/4 x minus 4. What I want to do is substitute my solution into both of those equations. Remember, my x is first, and then my y. So for this first equation, I'm going to write -1 equals 1/2 times -4 plus 1, just like that. So then let's simplify this. This is going to be -1, just bringing that down. 1/2 times -4. Well, what's half of 4? 2. So what's half of -4? -2. And then plus 1. Let's see, -1. Does it equal -2 plus 1? Yes, it does. That says -1 equals -1. So that means -4, 1 is a solution of the equation y equals 1/2 x plus 1. Now let's substitute -4, -1 into the other equation. So y is -1, and then I have -3/4 times -4 minus 4. Okay, so for this one, I'm going to remember that whenever I don't have a denominator for a number, whenever a number is an integer or a whole number, then I could write 1 as my denominator. I got that negative sign there. And then minus 4. Okay. So this is -3/4 times -4 over 1. -4 can be rewritten as -4 over 1. Whenever you don't have the denominator written explicitly, you can rewrite that as a fraction with the denominator of 1. So -1 equals, let's multiply our fractions. -3 times -4 is a positive 12. And in my denominator, I have a 4. And just checking, I have a negative and a negative here. So my product there should be positive. Okay, so 12 over 4 minus 4, that's -1 equals 3 minus 4, and that equals -1. So this is -1 equals -1. So all that means is that -4, -1, the point that we identified as the solution over here, also makes this equation true. It makes both of my equations true. So that's why we would say it's not just a solution to each equation, it is a solution to the system of equations. Now, here's something that I would normally do. I just did a lot of work by hand right here just to show you what I mean by these being this being a solution to both equations. You could have checked in Desmos, right? We could have done all of that work in Desmos and it would do it for us. But this was a good opportunity to practice a little fraction multiplication. Didn't hurt anybody. All right, so now we know what it means for a solution to be a solution to a system of equations. So let's look at another example. This one says, find the ordered pair that represents the solution to both equations. So this time we have to look at the graph and figure out what the solution is. I found it. Have you? It's right here. It's the point where the two lines intersect. That's all we have to do. All of these values over here, they're just extra. We don't need them. I could actually get rid of these values if I needed to. I don't have to write these down at all. This is extra information because what I'm looking for is the point where the two lines cross. Let me bring those back though. And let me write down the solution. It's at -12 for my x value. And my y value is, let's see, right here, right? I notice my y-axis is counting by 4s, so then that must be -2. So -12, -2 is my solution. And I just want to show you that I could also get the equation of these two lines, right? I don't need to. I'm already done. I already have the right answer. But if I wanted to get the equation of those lines, I could, because that's something we've already learned how to do by hand, and we've already learned how to do it with Desmos. Let's do it with Desmos here. So to type these values into Desmos, I would enter these two tables. I'm going to do that now, and you should pause the video, and you should also enter these two tables into Desmos. Once you've entered the tables, you're going to click the little button that looks like this for each one of them, and then it's going to graph each line for you. And the graph it should give you should look kind of like this. And notice that if you click on this point right here, this box is going to pop up and tell you the coordinates, which is -12, -2. So we just used a skill that we already knew, which was doing linear regressions in Desmos to plot some lines and get the equation of those lines. And then we clicked on the point of intersection and it told us the coordinate. It's just another way to see that -12, -2 really is the point that causes both equations to be true. Let's look at this one. A system of equations is shown. Find the x value of the solution. Well, first I'm going to draw the solution on the graph. It's where the lines intersect. It's right there. Okay, so the x value is 2 and the y value is -6. That's pretty easy. So it is the point 2, -6. And just pay attention when you're answering questions about solutions of systems of equations. Pay attention to what the question wants. Does it want an x value? Does it want a y value? Sometimes the question is asking for something specific. In this case, it's asking for both. Also pay attention to how your axis is counting. In this case, my x-axis is counting by ones, whereas my y-axis is counting by twos. So that's something we need to pay attention to and be mindful of. Let's look at one more. Chelsea and Bob both work 2 jobs. The graph shows the linear relationship between the number of hours worked at the first job and the number of hours worked at the second job. I'm going to go ahead and mark the solution on that graph and attempt to determine its coordinates. Sometimes it helps to draw a line from the point to the x-axis and the y-axis. For me, that makes it a little bit easier to see that. So 15 hours at job 1 and 25 hours at job 2 is where they're both working the same amount of hours at each job. Let me label this job 1 and job 2, just making it easier to interpret. Okay, so we know 1525 is our solution. At what number of hours does it appear that Chelsea and Bob will work the same number of hours at job 1? All right. So how many hours is that? Well, at job 1, they're both working 15 hours, right? This is our x-axis right there. And so our x value is 15 when they're the same. The next one says, at what number of hours does it appear that Chelsea and Bob will work the same number of hours at job 2? Well, when they're working the same number of hours at job 2, they're both working 25, right? That's our y-axis. So again, it's important to pay attention to what is the question asking for, and are we talking about x or are we talking about y?